Hey guys, this is Michael Crosby, and I'll be talking to you guys today about site reliability engineering. So, a site reliability engineer is a pretty new, well, it's been around for a few years, but it's a pretty booming field right now with a lot of companies demanding these engineers, but not as many out there as they'd like to see. So, I'm here to talk to you guys about some of the technology they use, some responsibilities they have, and who are the SREs. So typically an SRE comes from an operations or production support background. These are guys who just are sick of the repetitive tasks that come with operations, and they like to use some software engineering principles and apply them to operations and sysadmin problems. So these are people that hate doing the same repetitive tasks and love the idea of automating themselves out of a job. Some SRE responsibilities include availability, performance, monitoring, change management, emergency response, eliminating toil, and maintaining infrastructure. So we're going to dive into each one of these a little deeper in the next few sections. So availability. Availability in the past, systems had to be powered down and restarted for software updates to be deployed. This caused downtime and outages for customers. And in the past, this was viewed as okay, but in today's fast-moving digital world, customers expect access to their information and websites 24/7. Downtime is no longer being viewed as acceptable, and many companies strive for what we call a 5 nines availability, or 99.999% uptime. In order to achieve this level of availability, we use software tools such as Kubernetes to help maintain high availability during new software deployments. Using certain Kubernetes deployment strategies, as seen on the screen, allow new software to be rolled out into the production environment, aka the customer-facing world, with zero downtime when done correctly. Don't worry if you haven't heard of some of these terms on the screen. We'll dive deeper into these in future videos. Next, performance. It's important that SREs watch the performance of their systems by using KPIs, or key performance indicators, in their metrics to look for signals of impacted system performance. So what are these KPIs? Well, there's 4 main ones as defined by originally Google. So we have latency, which is how long it takes to complete a request. Traffic. Traffic is how many customer requests are being placed on your system. Saturation. What capacity is your system or service at? And errors. How many errors is your system seeing and requests that are failing? So monitoring. In order to know and understand our system performance from the last section, we need monitoring in place so that we can capture important metrics and logs. Once we know what threshold is too high for our service, then we would create an alert to notify the on-call engineer of an issue and the action needed to resolve the issue. There is a wide plethora of monitoring tools on the market, and they can be broken down into 2 types. We have log aggregation tools such as Splunk and the Elk Stack, and metrics tools such as New Relic, Prometheus. So a log aggregation tool such as Splunk is more focused on capturing the application logs of your system. So you would see things such as specific customer information going through, what people are trying to access, and then we have metrics tools such as New Relic and Prometheus. These are more along the lines of latency of systems and how long something takes to succeed if a system's down. Emergency response. So once an alert is triggered, it is sent to a notification service such as PagerDuty, which will notify or page the on-call engineer. This is where emergency response comes into play. The on-call engineer will need to start analysis of the issue and work to bring the system online as fast as possible. This is known as the MTTR, mean time to resolution. Ideally, all alerts are actionable and have an associated runbook so that the on-call engineer can immediately start triaging the issue. Each company will have a different expected time to acknowledge the page and troubleshoot the issue. Many companies have a 5-minute expected time to act and begin troubleshooting the issue, at least defined by Google. Also, a runbook is a we'll call it a confluence page that has a list of steps to follow to circumvent a known issue. Change management. Most issues and outages occur due to a change in the system from a software deployment. This is why making sure each deployment is tracked via a tool such as Jira or ServiceNow is so important. In today's agile world, deployments are happening at faster and faster rates, so SREs need a record log to view recent changes that can correlate with a newly discovered issue or outage. In my experience, the root cause of most issues is almost always a recent software deployment. And even in Google's SRE book, they mention somewhere along the lines of 70% of issues are caused by new software deployments. And one of my personal favorites, eliminating toil. So sysadmins and production support staff have to perform many repetitive tasks. One of the reasons why SRE has become so popular and one of the main philosophies is to apply a software engineering mindset to a system administration problem. Using software engineering, we can automate solutions for repetitive tasks. In my experience, two things I have automated are automatically updating ServiceNow tickets using Splunk to inject customer logs for their file failures, and the second is automating the process to grant customer support temporary admin access using Python, SQL Alchemy, Jira, and Docker. The goal of an SRE is to try and automate yourself out of a job. And last, maintain infrastructure. Depending on the company, this one can vary, but maintaining infrastructure is very important as it's the basis of your entire ecosystem and architecture. It doesn't matter if the software is working good if the server it's deployed on is having issues. Using infrastructure as code is a new way to maintain systems and make sure that everything is well recorded and maintained. IAC, infrastructure as code, also ensures that configuration drift doesn't occur so that all servers are identical. Having IAC also gives you a great view into what your architecture looks like without having to dig throughout your infrastructure at random to find servers. Terraform is my personal tool of choice as it's cloud agnostic, meaning you can use it on AWS, GCP, Azure, and it has a huge community with many plugins available to support. So that's it for the high-level dive of site reliability engineering. I hope you guys get interested in this field as it's, like I said, definitely booming and something that is going to grow even more exponential in the years to come.